This video demonstrates solving some equations where you need to use a trig identity first to be able to simplify. So at first glance here, I think I could maybe factor. However, I notice that I've got two different trig functions. So let's try replacing sine squared x with 1 minus cos squared x. Remember, we have the Pythagorean identity as sine squared x plus cos squared x equals 1. So I can replace sine squared x with 1 minus cos squared x. So what it leaves for me to do now is to expand and then rearrange my equation here. So I've got minus 8 cos squared x minus 10 cos x minus 3 is equal to 0. And now I want to see if I can factor this. So let's take a look. We are looking for two numbers that are going to multiply to minus positive 24, I guess here. And that are going to add to minus 10. So let's see if we can figure out any here. Remember, when you're factoring, you can use whatever method you would like to. Okay, you can use grouping, you can use the square, you can use the Australian method, any sort of expression here. When I am done factoring here, let's do an example of factoring by grouping. So if I break up minus 10 cos x into minus 4 cos x and then minus 6 cos x, I can now factor this by grouping, by factoring out minus 4 cos x from these first two terms. That is going to give me 2 cos x minus 1. And then on the right hand side, I can actually factor out minus 3. So now I've got minus 3 times 2 cos x minus 1, plus 1 on both of these here. And then what I can do is now I can factor out 2 cos x plus 1 from both terms. And that's going to leave me with 2 cos x plus 1 and minus 4 cos x minus 3. Now I've got two brackets that I can set equal to 0 that I'm going to be able to solve. So my first one here is cos x equals minus a half. And my second equation that I'm solving here is cos x equals 3 over minus 4. So let's do cos x equals minus a half. First, we'll do that as my solution 1. The first thing that I'm going to do is draw a sketch that is labeled. So cosine is negative in my second quadrant and my third quadrant. And so what I'm looking for is my related acute angle. Okay, my related acute angle is the cosine inverse of a half, which is one of our special triangles, which happens to be 60 degrees. Once we have that 60 degrees, I've got my solution in quadrant 2. And let's call that we're using x. So my solution in quadrant 2 is going to be 180 degrees minus 60, which is going to give me 120 degrees. I don't know why I have that 2 there. I don't really need that. It's just an x. Okay. And then I've got a solution in quadrant 3, which is going to be 180 degrees plus 60 degrees, which is going to give me 240 degrees as my second solution for that particular bracket. Now I need to solve my next equation, which is cos x equals 3 over minus 4. So I'm in the same quadrant. I'm still in 2 or 3, but this time my related acute angle is not from my special triangles. So I'm going to have to use my calculator to figure this one out. So I've got the cosine inverse of 3 over 4, or 0.75. So my related acute angle is about 41 degrees. So then my solution in quad 2 is going to be 180 degrees minus 41. And then my solution in quad 3 is going to be equal to 180 degrees plus 41. So my two solutions there are going to be 139 degrees in quadrant 2, and then 221 degrees in quadrant 3. Let's try another example. Here I've got 8 sine x cos x minus 2. And what I'm looking at here is a bit of a problem because I'm not sure how I'm going to solve that based on the identities that I know. So what I actually do have are some double angle formulas. Okay. So here I've got 8 sine x cos x. Okay. What I'm going to do first is I'm actually going to rewrite this as 4 times 2 sine x cos x. And then I've got minus 2. Now what I can actually do here is 2 sine x cos x is a double angle formula. And it is this identity here. This one is on your formula sheet. 2 sine x cos x equals sine 2x. So what I can do here is I'm going to replace this with sine 2x. And now I've got something that I can solve for here. I've got 4 sine 2x is equal to 2, which means that sine 2x is going to be equal to 1/2. So now what am I going to do here? So let's just let A represent 2x. So now the equation that I'm solving is sine A equals 1/2. So let's solve that like we normally do. Sine A is positive. That happens in the first two quadrants. And I'm looking for my related acute angle. Now that happens to be a special triangle, which is my 1, 2, root 3 triangle. And so my related acute angle there is 30. So now I would have my two solutions. So quadrant 1, my A would be equal to 30 degrees. And then in quadrant 2, my angle would be equal to 150 degrees. But I really do know that A is actually equal to 2x. So that means that x has to be equal to 15 degrees. And the same thing here, A is 2x equals 150. So that means I know that x has to equal 75 degrees. Those are my two solutions for this problem based on using that double angle formula to simplify it to one trig function. For my last example here, I've got sine 2x minus cos 2x, so almost the opposite of what I had in the previous one. Sine 2x I'm going to replace using the same identity that I did before. So 2 sine x cos x. And for cos 2x, I'm actually going to use another identity, which is cos squared x minus sine squared x. So let's make that replacement. And you do have some of the double angle formulas on your formula sheet. Okay, so now that looks a little bit better. I think I want to actually make that 1 into sine squared x plus cos squared x as well, so that I've got everything in terms of sine and cosine to see if I can simplify my expression a little bit. So let's keep going here. We'll do some expanding and some simplifying. What I'm going to see is that I get 2 sine x cos x minus cos squared x plus sine squared x plus sine squared x plus cos squared x. Now the first thing that you should notice is that these two are going to cancel out, and what I'm left with is 2 sine squared x plus 2 sine x cos x. Okay, equals 0. This is not the only way to do it. There are some other identities that you can use to get to the same spot. Okay, so before I continue, I'm actually going to divide out my 2's. The right-hand side is equal to 0, so I can do that all the way through. And then I'm going to factor out sine x from both of those terms. So now I've got now I'm going to have sine x times sine x plus cos x, which is going to be equal to 0. So I've got two equations that I'm solving. The first one is sine x equals to 0. I know that happens at 3 times between 0 and 360. So 0, 180, and 360, or 0, pi, and 2 pi if you're using radians. And then my next one is going to be a little bit trickier to solve. And I've got sine x plus cos x. So let's rewrite this as sine x equals minus cos x. And then I'm going to think about if there are any values where I can get that. So let's start by drawing out our 45, 45, 90 triangle, because I know that I'm going to have some opposite values here because my x and my y are equal to each other. So I've got 1, 1, and root 2 with an acute angle of 2 45s. So if I draw that out here, I know that in my first quadrant, all the ratios are positive. So that is something that can't happen. So I don't have any quadrants solutions in that quadrant. In my third quadrant here, both sine and cosine are negative. So I also can't have any solutions where sine x is equal to negative cos x. So no solutions there either. So my only two solutions are going to be in my second quadrant or in my third quadrant, because those are the areas where sine x is positive and cosine is negative, or vice versa. So for this situation, my related acute angle is going to be 45 degrees, or pi over 4. And then what I have here is my first solution in quadrant 2, which is going to be, what's my first solution here? I would have 180 degrees, take away my related acute angle of 45, which is going to give me a solution of 135 degrees. And then I'm also going to have a solution in quadrant 4, which is going to be x equals 360 degrees, take away 45, which is going to give me x equals 315 degrees. Those are the two solutions that are going to satisfy that relationship.